Welcome to our tutorial on utilizing MATLAB to evaluate essential vector operations. We're going to evaluate gradient, divergence, and curl. For example, the gradient of voltage gives us minus the electric field. On the other hand side, the divergence of electric field density D gives us the charge density per unit volume rho. And curl electric field is equal to the partial derivative of magnetic density with respect to time. Let's briefly explain these concepts. The gradient represents the rate of change or the slope of a scalar field. Divergence measures the flow of a vector field out from a point. Curl evaluates the rotation or circulation of a vector field. Let's consider an example where the voltage V is given as 2x squared plus y cubed z. To calculate the gradient of this voltage, we will find the partial derivative of V with respect to each variable. First, the partial derivative with respect to x is 4x. All other variables are considered to be constant. Second, the partial derivative with respect to y. This gives us 3y squared times z. And finally, the partial derivative with respect to z. This gives us y cubed. So the final answer is going to be as follows. The gradient of v is equal to 4x, the x direction, plus 3y squared z in the y direction, and finally y cubed in the z direction. So the gradient of a scalar is a vector. Okay, let's switch to MATLAB and check our answer. I'm going to define the function V voltage using the symbols x, y, and z. The voltage is 2x squared plus y cubed multiplied by z. To find the gradient of this voltage, all I need to do is just to type gradient followed by V. Now we got the components. 4x in the x direction, 3y squared times z in the y direction, and finally y cubed in the z direction. Let me show how you calculate the gradient at certain point in MATLAB. To calculate this gradient at point 1, 2, 3, I'm going to use the function substitute. We are replacing x, y, and z by 1, 2, and 3. And here's the answer. Divergence is similar to gradient. We will use the del operator. The only difference is that gradient is calculated for a scalar quantity and divergence is calculated for vector quantity, and the result of divergence is going to be scalar. We need to apply dot product between the del operator and the electric field density D. Applying dot product means we're going to find the partial derivative of x component with respect to x, the partial derivative of y component with respect to y, and the partial derivative of z component with respect to z. And the answer is going to be as follows. 2x plus z plus 3z squared. The answer is scalar quantity. Let's check our answer using MATLAB. To enter the vector D, we enter its components, and then we use the command divergence. For our given electric field, sine x in the x direction, cosine x in the y direction, and 10 in the z direction, let's calculate curl E. Simply, curl E is the cross product of the del operator and E. The x direction, the derivative of 10 with respect to y is 0, and the derivative of cosine x with respect to z is 0. Now, in the y direction, the derivative of 10 with respect to x is 0, and the derivative of sine x with respect to z is 0. Finally, in the z direction, the derivative of cosine with respect to x is minus sine, and the derivative of sine x with respect to y is 0. So the final answer is minus sine x in the z direction. We define the electric field and then we apply curl function. Thank you for watching.